Namaskaram everyone. This is Sri Devi, Principal of PSMS Shankarampetar. I take the pleasure of welcoming you all for another day of Junior Intermediate webinars. To begin with, we have Mathematics webinar, then we have Zoology, Physics and Political Science for today. And in today's Mathematics 1A session, you will be learning about trigonometry, multiple and submultiple angles of trigonometry. So far, you have already attended 2 sessions in which the introduction was given in an elaborate manner, and also the compound angles were discussed in the previous session. I take this opportunity to invite and welcome Mrs. B. USHASREE, PGT Mathematics from TSMS Velimela, to continue her session on trigonometry, which she's going to discuss multiple and submultiple angles and few more problems which are very important for you to understand the concept very well. Madam, I'm so delighted to have you. Over to you, Usha, madam.
Thank you, madam. Dear children, I welcome you all to this session of trigonometry. I'm sure that you have worked out the problems which I have given on the other day in the practice session. And I'm very sure that you have completed the application part of compound angles, right? Having said that, we will just try to see some more problems relating the trigonometric ratios with compound angles. And of course, we will never forget to use ASTC property and the signs and the values of trigonometric ratios in the different quadrants throughout the first year syllabus. Right, children? Now, today we will look into problems relating trigonometric ratios of compound angles. Then we will try to derive some formulae based on what we have seen in the last session. And then we will try to see what exactly is the meaning of multiple and submultiple angles with these trigonometric ratios. To start with, let us start with a problem which is using the compound angles concept, what we have discussed in the previous session. Now, if a plus b is equal to pi by 4, what is pi by 4? Pi is 180, right? 180 by 4, which is 45 degrees. So a plus b is equal to 45 degrees. Then you're asked to prove that 1 plus tan A into 1 plus tan B is equal to 2, and cot A minus 1 into cot B minus 1 is equal to 2. Right? Now, how to go with this problem? We will try to make use of the condition what is given to us, and we will try to get tan and cot terms into the problem so that we can get this proof. We can solve this, the first and second bits. Right. So you are given that a plus b is equal to 45 degrees, that is pi by 4. Then, since in the first bit we have tan terms, we will apply tan on both sides. When we apply tan on both sides, we will get it as tan of a plus b is equal to tan of pi by 4. Tan of a plus b, we have seen the formula, children. What is it? Tan of a plus b is tan a plus tan b by 1 minus tan a tan b. And here tan 45, tan pi by 4 is tan 45, which is equal to 1. Right? We'll go for cross multiplication. Then we'll have it as tan a plus tan b is equal to 1 minus tan a tan b. Now we'll make use of this condition and we will try to substitute this in the simplification what we have in the first bit. Now we'll take the LHS of the problem. 1 plus tan A into 1 plus tan B. We will just multiply, children, as we do in any algebraic expression, right? Here in trigonometry also it applies. So 1 into 1, which is 1, tan A into 1, which is tan A, then tan A plus 1, which is tan A, 1 into 1, 1 into tan B, tan A into 1, and tan A into tan B. So you are left with 1 plus tan A plus tan B plus tan A tan B, right? This is simple multiplication. Now, just now, when we have applied tan on both sides for the given condition, we got it as tan A plus tan B is equal to 1 minus tan A tan B, right? Instead of tan A tan B here, we will try to substitute 1 minus tan A tan B in the simplification, right? So we are just replacing this tan A plus tan B with 1 minus tan A tan B here, right? And of course, you have the remaining two terms as it is. Now, 1 plus 1, which is 2, minus tan A tan B plus tan A tan B, they get cancelled. So you are left with 1 plus 1, which is equal to 2. This is what we need to prove, right? 1 plus tan A into 1 plus tan B is equal to 2, right? Therefore, we got RHS. So we can conclude that 1 plus tan A into 1 plus tan B is equal to 2. Likewise, to solve with the second bit, what is that you have in that LHS or in the second bit? The terms are in cot form, right? Cot of some angle. Therefore, the same logic what we have followed for the first bit, we will follow for the second one also. We will apply cot for the given condition on both sides. So a plus b is equal to pi by 4 is the condition which is given to us. Therefore, cot of a plus b is equal to cot pi by 4. Cot pi by 4 is again 1, and cot of a plus b, we have already seen the formula in the previous sessions, that is cot a cot b minus 1 by cot b plus cot a is equal to 1. Okay, then we'll just go for cross multiplication, children. Cot a cot b minus 1 is equal to cot b plus cot a. Now we'll just take the LHS of the problem. The problem is cot a minus 1 into cot b minus 1. Start multiplying. Cot a cot b minus cot a into 1 is cot a, minus 1 into cot b is minus cot b. So I have taken minus common from these two terms, plus 1. Minus 1 into minus 1, which leaves plus 1 over here, right? Now, if you expand this, before expansion, see children, the condition what we got is cot a cot b minus 1 is equal to cot b plus cot a. Now, instead of cot a plus cot b, we can replace it as cot a cot b minus 1. So the bracket part, whatever you have, it is replaced with cot a cot b minus 1. Now when we do that, cot a cot b gets cancelled because you have one term with plus and the other one with minus. So they get cancelled. Minus into minus, which is plus 1, 1 plus 1 is equal to 2. Therefore, 2 is your RHS. Hence, we can conclude saying that cot A minus 1 into cot B minus 1 is equal to 2. Now, this type of problems generally, if you are given with it, if 2 bits are given to you, it may be considered for a 4-mark problem also. And a simple one, isn't it? Just an application of the formula. We are deriving something from the application directly, and then we are just applying that in LHS part to get your solution. Right. The next problem is find tan of pi by 4 plus a in terms of tan a. Pi by 4, 45 plus a, this can be considered as a formula also, or in fact it is an application of the compound angles like what we have seen just now, tan of a plus b form. But only thing is, when you simplify certain problems in your MSET exam, it will be very convenient for you if you can remember the formula or the answer for this. Okay. So tan of pi by 4 plus a in terms of tan a, and also cot of pi by 4 plus a in terms of cot a. Now, tan of pi by 4 plus a. Now it's something like tan of a plus b only, isn't it? So we'll go for the application of the formula. Tan of a plus b is equal to tan a plus tan b by 1 minus tan a tan b. Now instead of a, you can consider pi by 4, and instead of b, you have a. Just substitute these two values in the formula. Then you have tan pi by 4 plus tan a by 1 minus tan pi by 4 tan a. Tan pi by 4 is 1, isn't it? So 1 plus tan a by 1 minus, this is of course tan of pi by 4 is 1 again. So 1 minus tan a. So tan 45 plus a is nothing but 1 plus tan a by 1 minus tan a. Likewise, you can also calculate tan of pi by 4 minus a also in terms of tan a. Right? Now in that case, your answer will be 1 minus tan a by 1 plus tan a. You can just try it out, children, immediately after this class. Then cot of pi by 4 plus a. Cot of pi by 4 plus a is what? Again, we are applying the compound angles for trigonometric ratios. From that, cot of a plus b we will take. Cot of a plus b is equal to cot a cot b minus 1 by cot b plus cot a. Right, we will just substitute pi by 4 in the place of a, and in the place of b we will substitute it as a. We will have it as cot pi by 4 cot a minus 1 by cot a plus cot pi by 4. Cot pi by 4 is also 1, isn't it? Therefore, you will have it as cot a minus 1 by cot a plus 1. Now, here again, you can also calculate cot of pi by 4 minus a in terms of cot a. Just try out what I have mentioned, children, after the class, right? Now, again, an important problem from your examination point of view. Of course, you need to learn the concept also. Now, if tan theta is equal to cos 11 plus sin 11 by cos 11 minus sin 11, and theta is in the third quadrant. Just keep this in mind. Theta is in the third quadrant, and you need to find the value of that theta. Okay, children. Now we'll just consider cos 11 plus sin 11 by cos 11 minus sin 11. Now, if you look at this, there is no formula for us which is convenient to apply over here. But we need to simplify it. And how you need to simplify it? What should be your target? On the other side, you have tan theta. That means you should convert this term, whatever you have, or this expression in terms of tan. So tan is possible whenever you have sin by cos. So in the denominator, the target is you should have some cos term. Then only sin and cos can be converted into tan. So this is the reason why we are picking a concept, or we are picking an idea like dividing numerator and denominator with cos 11. When we do so, right, cos 11 plus sin 11 by cos 11. That means I am taking cos 11 in the denominator for each and every term in the numerator, and in the denominator also we are dividing with cos 11. Right, children? So here cos 11 and cos 11, they get cancelled, and here in the denominator also. Then sin 11 by cos 11 gives you tan 11. Now look at this. Tan of pi by 4 plus a is equal to 1 plus tan a by 1 minus tan a. Just now we have seen this formula, right? So application of this we are going to take here. This is 1 plus tan 11 by 1 minus tan 11. Now what is this exactly? Instead of a, you have 11. That means I can always write this as tan of 45 plus 11. Now look at this. We have taken the RHS of the problem. We have converted that in terms of tan. Why we have converted in terms of tan? Because your left hand side has got some tan theta and we need to find out theta. right? So this is nothing but tan 56. But where will be tan 56, children? 56 degrees will be in which quadrant? It will be in the first. But what is that we need to do? We need to find a theta value in the third quadrant, right? Now we all know that all the trigonometric ratios are periodic. Now the same value, whatever you get for tan 56, can be seen in different quadrants again. Now here, when I say tan 56, it is a positive value because it is in the first quadrant. Now, positive value is possible for tan in the third quadrant, right? So we'll say since theta is in the third quadrant, it is mentioned, isn't it? So tan theta is equal to tan of 180 plus theta. Tan of 180 plus theta is also tan theta. So here our theta, we are taking it as 56 degrees. So we will get it as tan of 236 degrees. Therefore, we will conclude saying that theta is equal to 236 degrees. Hope the problem is clear, and you have many examples in your textbook also based on this concept. I want you to try out, and this is an important problem for 2 marks. Regularly it will be repeated in your IPE exams, and this concept can be asked in your MSET also. Right. Now, based on the compound angles, what we have seen, sine of A plus B, sine of A minus B, cos of A plus B, cos of A minus B, and so on, we can also deduce few more formulae that we will look into now. Sine of A plus B into sine of A minus B. Now, you know what is sine of A plus B and sine of A minus B. Just we'll go for multiplication of these two terms by applying the formula. What is sine of A plus B? Sine A cos B plus cos A sine B. And likewise, sine of A minus B is sine A cos B minus cos A sine B. Isn't it? We will start multiplying these two. Now, how are these two terms in the bracket look like? They are in the form of A plus B into A minus B. So we can simply write it as A square minus B square form. So you will have it as sine square A cos square B minus cos square A sine square B. Now, instead of cos square B, we have trigonometric identities, children. Sine square theta plus cos square theta is equal to 1. So what will be cos square theta? It will be 1 minus sine square theta, isn't it? So instead of cos square B, we will replace it with 1 minus sine square B by making use of the identity, right? And likewise, instead of cos square A, we can always replace it with 1 minus sine square A into sine square B. Just we are replacing the cos terms in this step. Right? We will expand this. You will have it as sine square A into 1, which is sine square A, minus sine square A into sine square B. Right? Minus 1 into sine square B, which is minus sine square B, and minus into minus plus sine square A sine square B. Now, sine square A and sine square B, they get cancelled. Then we will be left with sine square A minus sine square B. So we can say sine of A plus B into sine of A minus B is equal to sine square A minus sine square B. Now the same formula can be expressed in terms of cos also. How to do that? Instead of sine and sine terms here with A and B angles, we can always substitute 1 minus cos square A here and 1 minus cos square B here by making use of the trigonometric identity. So you have it as 1 minus cos square A minus 1 minus cos square B. Now 1 and minus 1, they get cancelled, children. So you will have it as minus cos square A minus into minus plus cos square B. Therefore you have it as cos square B minus cos square A. So here we can conclude saying sine of A plus B into sine of A minus B is nothing but sine square A minus sine square B, and also it can be expressed in terms of cos by writing cos square B minus cos square A. Now similarly, making use of cos of a plus b into cos of a minus b, you can also deduce such type of formula. Right? You can try it out. I'm just leaving the answer over here. Cos of a plus b into cos of a minus b is equal to cos square a minus sin square b. And it can also be taken as cos square b minus sin square a. Right? You need to check this answer, children. And you just satisfy yourself by solving this like how I did for sin of a plus b into sin of a minus b. Now, we will try to make use of these two formulae and we will solve some 2-mark questions which will be generally asked in your IPE exams. Now, evaluate cos square 112.5 degrees minus sin square 52.5 degrees. Right? Now, just now we have seen the formula cos of a plus b into cos of a minus b. See, when you have taken sin of a plus b into sin of a minus b, you are able to express the answer purely in terms of sin or purely in terms of cos. But sin and cos combination is possible with cos of a plus b into cos of a minus b only. So certain things you need to design yourself to remember the formula, children. Everyone will have their own style of remembering the formulas, right? So hope that you will try to come out with your own ideas to remember this formula, right? Cos of a plus b into cos of a minus b. We have seen it as cos square a minus sin square b, right? So we will just apply the formula over here by taking a is equal to 112.5 degrees and b as 52.5 degrees. Now, applying this formula, you will have it as cos of 112.5 degrees plus 52.5 degrees into cos of 112.5 minus 52.5 degrees, right? So when you add these two, you will get it as cos of 165 and 112 minus 52, which leaves 60 over here. Of course, half and half also get cancelled. So you will have it as cos 60. Now, cos 60 is what? Yes, it is half. But cos 165 we have not seen directly, right? It is not a standard value. So you need to again simplify further by making use of your concept of compound angles, and you need to get the value of cos 165 degrees, right? So cos 165, we will write it as cos of 180 minus 15. And of course, cos 60, we know it is a standard value. So we are substituting it as half. Now, cos of 180 minus 15. Cos of 180 minus 15. Do you remember where we have used this? In the first session, when we were discussing ASTC property and also the values of trigonometric ratios in different quadrants, right? 180 minus theta, it falls in which quadrant? It is in the second quadrant. How is cos in the second quadrant? It is negative, right? So you will have a minus sign over here, and cos of 180 minus theta is cos theta only. So you will have it as minus cos 15. So minus cos 15 into half. Right? Now, cos 15 degrees. On the other day, when I was discussing compound angles, we have deduced the values of sin 75, cos 75, sin 15, cos 15, and so on, isn't it? Right? So we will apply that formula directly, and of course the values what we have deduced over there. So cos 15 is nothing but root 3 plus 1 by 2 root 2. Right? Simplifying this, you will have it as minus root 3 plus 1 by 2 into 2. Of course, it is 4 root 2. Therefore, we can conclude saying that cos square 112.5 degrees minus sin square 52.5 degrees is equal to minus of root 3 plus 1 by 4 root 2. Now, we will try to apply the same, the formulas what we have deduced with one more problem, children. Sin square and sin square, right? So sin square of pi by 8 plus a by 2 minus sin square of pi by 8 minus a by 2. Now, Sine and sine square and sine square is possible only when you have sine of a plus b into sine of a minus b, right? So sine of a plus b into sine of a minus b is equal to sine square a minus sine square b. Now, instead of a, what do you have? You have pi by 8 plus a by 2. And instead of b, you have what? Pi by 8 minus a by 2, right? We will just substitute these two, children. So you will have it as sine of pi by 8 plus a by 2 plus pi by 8 minus a by 2 and sine of pi by 8 plus a by 2 minus of pi by 8 minus a by 2. Just substituting a and b values in the formula. Then here in the first bracket, a by 2 and minus a by 2, they get cancelled. And here we will have pi by 8 and minus pi by 8 getting cancelled, right? Now, when they get cancelled, you will be left with sine of 2 pi by 8. Pi by 8 plus pi by 8 is 2 pi by 8. A by 2 minus of minus plus a by 2. A by 2 plus a by 2 is a. So sine 2 pi by 8 sine a. Now what is 2 pi by 8, children? 2 and 8 gets cancelled, isn't it? So you will have it as pi by 4. What is sine pi by 4? 1 by root 2. And of course sine a remains as it is. Therefore sine square pi by 8 plus a by 2 minus sine square pi by 8 minus a by 2 is nothing but 1 by root 2 into sine a. Now further proceeding with the next problem. If you have a condition like a plus b plus c is equal to pi by 2, right? Then is asking you to prove that cos a plus cot a plus cot b plus cot c is equal to cot a cot b cot c. Then tan a tan b plus tan b tan c plus tan c tan a is equal to 1. And then the last one is sigma cos of b plus c by cos b cos c is equal to 2. All right. Now the problem what I have started with, when a condition is given to you, we are just applying tan and cot on both sides by looking into the question asked. If it is in terms of tan, we are applying tan. If it is in terms of cot, we are applying cot. Right? And here a plus b plus c is given as pi by 2. This is the condition. Now making use of this condition, we will start with the first bit, children. In the first bit, you are asked some problem in terms of cot. So first to start with, we will say we don't have any formula directly with a plus b plus c is pi by 2, right? So when you have such type of cases, you will just move one of the terms to the other side and you will reduce that with only two angles on one side. Otherwise you will have to remove the you will have to remember the formulas with a plus b plus c, a plus b minus c and so on. It will be a very lengthy process to remember all these formulae, right? So sometimes this will be the shortest way to solve the problems. Now a plus b is equal to 90 minus c. Pi by 2 is 90, isn't it? Now what do you want? In the first bit, all the problem is in terms of cot. So we will apply cot on both sides. Now here, cot of 90 minus c. Cot of 90 minus c will be tan c, isn't it? This is what we have learned, right? Cot of a plus b also we have seen, children. What is cot of a plus b? Cot a cot b minus 1 by cot b plus cot a, which is equal to tan c. Now children, we are getting one tan term which we don't want because we want all the terms to be in cot. But we know tan theta is nothing but 1 by cot theta, or we can also say cot theta is 1 by tan theta, isn't it? So tan c will be replaced with 1 by cot c, and we will go for cross multiplication. When we go for cross multiplication, you will have cot b plus cot a into 1 and cot c into these two terms. So you will have it as cot a cot b is equal to cot a cot b cot c, right? Cot a cot b cot c minus cot c. Now, cot C, you shift to the left-hand side. Then you will have it as cot A plus cot B plus cot C is equal to cot A, cot B, cot C. Now, you got the solution, right? Now, what is the second bit you have? Second bit is totally in terms of tan. That means we are taking the condition and we are writing A plus B is equal to 90 minus C. Now, what should be the logic, children? You should apply tan on both sides. So, tan of A plus B is equal to tan of 90 minus C. Then, tan of A plus B is tan A plus tan B by 1 minus tan A tan B, which is equal to tan of 90 minus C is cot C. As I was mentioning just now, tan theta is 1 by cot theta, or cot theta is equal to 1 by tan theta. So here we want purely in terms of tan. So we will replace cot C with 1 by tan C. When we do so, tan A plus tan B by 1 minus tan A tan B, which is equal to 1 by tan C. Go for cross multiplication, children. You will have it as tan A in tan A plus tan B into tan A plus tan B into tan C gives you tan C tan A plus tan B tan C is equal to 1 minus tan A tan B. Now, this tan A tan B shifted to the left hand side. You will have it as tan A tan B plus tan B tan C plus tan C tan A is equal to 1. We are rearranging the terms just for our convenience, that's all. All right. So the final step, what we are getting is tan A tan B plus tan B tan C plus tan C tan A is equal to 1. Right. Now we got all the terms purely in terms of tan, and we got the RHS also. Now the last bit what we have seen is with sigma. Sigma cos of B plus C by cos B cos C. Now before I take sigma and explain what it is, first I will see what is cos of B plus C by cos B cos C. Now you know the formula for cos of B plus C, children, isn't it? So you can just replace that by writing cos B cos C minus sin B sin C by cos B cos C. Now, if you just take this denominator for each of the terms, then you will have it as cos B cos C by cos B cos C, which is equal to 1, right? And sin B sin C by cos B cos C. Sin B by cos B is tan B. Sin C by cos C is tan C. So we will get it as 1 minus tan B tan C. Right? Now, this is your question. Sigma cos of B plus C by cos B cos C. Now, what is the meaning of this sigma? You are adding all the terms of this form. What is this form? Cos of B plus C by cos B cos C. Now children, in trigonometry, we are dealing with 3 angles. Now these 3 angles should be taken with the sigma. And you are adding the terms of all this type. It means the next term will be cos of C plus A by cos C cos A. And the next term will be cos of A plus B by cos A cos B. So A, B, C are taking the cyclic form. And you are adding all such terms. That's the reason why you are writing it as sigma. Now, the value of cos of B plus C by cos B cos C, we are just replacing it with 1 minus tan B tan C. Now, why did I simplify this right in the beginning? Instead, I can write the whole expansion of cos of B plus C by cos B cos C, isn't it? Just to make the problem simpler, we are taking this logic. We are simplifying for one term and we are applying for the remaining terms, right? So, your first term will be 1 minus tan B tan C. Of course, sigma means addition of all these terms, isn't it? So your next term should be 1 minus tan C tan A, and the next term will be 1 minus tan A tan B. right? So we will expand this, or we will simplify it further. 1 plus 1 plus 1, you have it as 3, minus tan B tan C, tan C tan A, and tan A tan B. All these terms, they are with minus sign. So we will take minus common and we will write all these terms, children. Tan B tan C plus tan C tan A plus tan A tan B. But just now in the second bit, what we have seen is tan A tan B plus tan B tan C plus tan C tan A is equal to 1. So I can replace the terms in the bracket with 1. So 3 minus 1, which is equal to 2. Right? So this is the solution of this problem, children. Now, if you don't want to do the problem in this method, then what is the other style of doing this? Just go with cos of B plus C by cos B cos C plus cos of C plus A by cos C cos A plus cos of A plus B by cos A cos B. For every term you simplify in this manner and then you add it. Now, instead of doing the same steps 3 times, we have solved it 1 time and then we are applying this sigma. Okay. I'm sure that you have observed this, right? Then find the value of tan 56 minus tan 11 minus tan 56 tan 11, right? Now 56 degrees, 11 degrees. Now with this, you can, tan 56 can be always taken as tan 45 plus 11. 45 plus 11 is what? 56, isn't it? So tan 56, we can write it as tan 45 plus 11. Now, how is this looking like? Tan pi by 4 plus theta form. Just now, we have seen this formula, isn't it? So, you can directly write, instead of using the formula like what I have used, you can directly write it as 1 plus tan 11 by 1 minus tan 11, if you can remember the formula. Otherwise, tan of A plus B, you will apply tan A plus tan B by 1 minus tan A tan B. In that way also you can solve it, right? Now, go for cross multiplication, children. Tan 56 minus tan 56 tan 11 is equal to 1 plus tan 11. Now, what do you want? You want tan 56 minus tan 11 minus tan 56 tan 11. That means you shift this tan 11 to the left hand side. Then you will have it as tan 56 tan 11 minus tan 56 tan 11, which is equal to 1. So directly you got the solution. Now, whatever expression he is asking, the value of that is equal to 1. Right? Now, the next problem, if sine of alpha plus beta by sine of alpha minus beta is equal to a plus b by a minus b, then prove that a tan beta is equal to b tan alpha. This is your problem, children. So you are given that sine of alpha plus beta by sine of alpha minus beta is equal to a plus b by a minus b. Right? Now, actually, how is this looking like? Some a plus b by c plus d form. If you have a plus b is equal to, a by b is equal to c by d, then there is one method called componendo dividendo. In this method, when you apply, you can write this as a plus b by a minus b is equal to c plus d by c minus d. Now, numerator, you are fixing, the numerator of the given condition is fixed here in this place. Then the denominator is added and subtracted in the numerator and denominator respectively on either sides. Now, you can also subtract in the numerator and add in the denominator. It hardly makes any difference. But when you are adding on the left hand side in the numerator, the same thing should be taken on the right hand side also. Now here you are adding in the numerator, but if you are subtracting here, now that is not correct. Okay. So by componendo dividendo, you can always write the this condition can be taken it as, by applying componendo dividendo, you can write it as a plus b by a minus b is equal to c plus d by c minus d. Now, making use of this logic, we will try to solve this problem, children. So we will apply componendo dividendo for this statement what is given to us. So what is your a here? Sine of alpha plus beta. What is b? Sine of alpha minus beta. Instead of c, what do you have? A plus b. And instead of d, we have a minus b. Now, keeping this in mind, we will just apply the formula. Sine of alpha plus beta, we are expanding. Sine alpha cos beta plus cos alpha sine beta. Of course, in the numerator and denominator. Look at this, a and a. So I'm just fixing this a and a in the first place. Then you have plus sine of alpha minus beta is sine alpha cos beta minus cos alpha sine beta. In the numerator, we are adding this. In the denominator, we are subtracting. Right? Now, this is equal to a plus b plus a minus b. So you will have b and b getting cancelled. You'll be left with 2a. A minus a plus b minus of a minus b, which gives you 2b. Right? A and a, they get cancelled. Now here, if you simplify, cos alpha sine beta with plus and minus signs, they get cancelled. And likewise in the denominator, sine alpha cos beta and minus sine alpha cos beta, they get cancelled. Then you will be left with, what is left here, children? Sine alpha cos beta plus sine alpha cos beta, which gives you 2 sine alpha cos beta. In the denominator, you will have 2 cos alpha sine beta. Right? And of course, on the right hand side, you have 2a by 2b. 2 and 2, they get cancelled here. And of course, on the right hand side also. Then sine alpha by cos alpha is what? It is tan alpha. Cos beta by sine beta is what? Tan beta, isn't it? So tan alpha cot beta is equal to a by b. But look at your answer, children. You are getting 2 tan terms. That means cot should be converted to tan. How will convert this cot in terms of tan? Cot is nothing but 1 by tan, isn't it? So instead of cot beta, you will write it as 1 by tan beta. So you will have it as tan alpha by tan beta is equal to a by b. Go for cross multiplication. Then you will have a tan beta is equal to b tan alpha. Now hence your result. Now this is a new method what you have seen. I want you to revisit this channel and go through this problem at least 1 or 2 times till you understand this. Okay. Quickly, we will see the next concept, trigonometric ratios of multiple and submultiple angles. You are familiar with what is a multiple, isn't it? And submultiple we are seeing now. Now, all this time when we were talking, all the trigonometric ratios, we are just trying to calculate by taking some angle. Without angle, there is no meaning for any trigonometric ratio, isn't it? So, when we were talking of angle, we said it is theta, sometimes it is A and B and so on. Now, when we have taken compound angles, A plus B, A minus B type of concept we have dealt with. Now, if A is an angle, then 2A, 3A, 4A, that means when you're multiplying an integer with the given angle, you will get multiples of that angle, isn't it? This is a simple concept what you have seen in the previous classes, like multiples of 2, multiples of 4 and so on. The same thing here. Multiples of a given angle, they will be generally taken as 2A, 3A, 4 and so on. But if you are talking of submultiple angles, then you will get in the fractional form. That is, it is multiplied with 1 by 2 or 1 by 3 or 1 by 4 and so on. So an angle multiplied with a fraction like 1 by 2 or 1 by 3 and so on gives you submultiple angles of the given angle, right? So with this small idea, we will quickly see what is the formula for sine 2a. Sine 2a, children. this is a multiple angle of A, sine 2A. 2A directly, of course, you can remember, but we'll try to do a little of derivation by making use of compound angles. 2A can be taken as A plus A. Now it is looking like sine of A plus B, right? So sine of A plus B is what? Sine A cos B plus cos A sine B. But instead of B also you have it as A. So sine A cos A plus cos A sine A. Now what is it equal to? It is 2 sine A cos A. Now this is the formula for sine 2A. Sine 2A is what, children? 2 sine A cos A. Likewise, cos 2A to calculate with, again we will take cos of A plus A. What is cos of A plus B formula? Cos A cos B minus sin A sin B, isn't it? Now instead of B you have A. Therefore, cos A into cos A minus sin A into sin A. So we can write it as cos square A minus sin square A. Now, cos 2A is cos square A minus sin square A. But suppose if you want this purely in terms of cos, then you should replace sin square A as 1 minus cos square A by making use of trigonometric identity. Then cos square A plus cos square A will be 2 cos square A. Of course, you have minus 1. So in terms of cos, if you want to write the value for cos 2A, then it will be 2 cos square A minus 1. Now, if you want this purely in terms of sine, then you will have it as, instead of cos square A, you just replace it with the trigonometric identity, that is 1 minus sine square A. Then you have it as 2 minus 1, which is 1 minus 2 sine square A. Therefore, we can write cos 2A in 3 forms. One is cos square A minus sine square A. The next one is 2 cos square A minus 1. And the last one is 1 minus 2 sine square A. Now children, this sine and cos 2A formulae we have seen in terms of sine and cos only. But you can also replace this sine 2A and cos 2A in terms of tan also. You can express this in terms of tan. Now for this one, sine 2A is what? 2 sine A cos A. Now 2 sine A cos A can be taken as 2 sine A cos A by 1. But what is 1? 1 is represented with an identity in trigonometry, that is cos square A plus sine square A. So you can also write 2 sine A cos A as 2 sine A cos A by cos square A plus sine square A. We will divide a numerator and denominator with cos square A. When you do so, you will have it as 2 sine A cos A by cos square A by cos square A plus sine square A by cos square A. Now, cos and cos, they get cancelled. So you have 2 sine A by cos A, which is 2 tan A. And here cos square A by cos square A, they get cancelled. You will be left with 1 over here plus sine square A by cos square A is tan square A. Therefore, we can write it as 2 tan A by 1 plus tan square A. That means sine 2A can also be written as 2 tan A by 1 plus tan square A purely in terms of tan. Now, likewise, if you go with cos 2A also can be represented in the form of tan. In terms of tan, you can write it as, look at this children, cos square A minus sine square A is the formula. Of course, this can be taken as cos square A minus sine square A by 1. Instead of 1, how we have replaced it with the trigonometric identity, we'll do the same here. Then, we will divide numerator and denominator with cos square A. When we do so, you will have it as cos square A minus sine square A by cos square A. And in the denominator, you have cos square A plus sine square A by cos square A. Then cos square A by cos square A gives you 1. Tan sine square A by cos square A gives you tan square A. The same thing over here in the denominator also. So we can conclude saying that cos 2a is nothing but 1 minus tan square a by 1 plus tan square a. So totally for sin 2a, you have seen 2 formulae. For cos 2a, you have seen 3 formulae. That is in terms of sin, in terms of cos, in terms of sin and cos, in terms of tan. Right, children? All these formulae, they will be useful. Of course, you can deduce one from the other, but only thing is if you can remember this, that will save your time when you are attempting any multiple choice questions. Right? Now, likewise, tan 2a, when you apply the compound angles concept, you will be getting 2 tan a by 1 minus tan square a. Right? And likewise, cot 2a, cot of a plus a, that is cot a minus 1 by cot a plus cot a, which is cot square a minus 1 by 2 cot a. Now, these are the formulas what we have seen. Now, from this multiple angles, see, when I say multiple angles, it is sine 2a, cos 2a, and so on. We have submultiple angles also, like 1 by 2, 1 by 3, and so on, right? Now, when you have sine 2a, you are getting it as 2 sine a cos a, but you can also write that formula in this form. See, when you have 2a, here you are getting in the answer as a and a. If you have a over here, then it should be a by 2, half of this angle, isn't it? So sine a can be taken as 2 sine a by 2 cos a by 2. Cos a is cos square a by 2 minus sine square a by 2. You can also write it as 2 cos square a by 2 minus 1 and 1 minus 2 sine square a by 2. Tan a, by replacing a with a by 2 in your answer, you will have it as 2 tan a by 2 by 1 minus tan square a by 2, and cot a can be taken as cot square a by 2 minus 1 by 2 cot a by 2. See, children, you need not remember all this. Now, if you can get the answer, or if you can remember the formula for sine 2a, you can also write for sine a. You can also write for sine a by 2 and sine a by 4 also, by making use of this logic. Now here, whatever angle you have, it will be exactly half, which you will be seeing on your other side of the equality. Okay. Now, we will look into sine 3a formula. Sine 3a formula, directly I am giving this, children, because I know you will try out this. Instead of 3a, you can write it as a plus 2a. Now you know what is the value for 2a, and also what is the formula for sine of a plus b, and so on, compound angles. Then I'm sure that you will deduce these formulae. Sine 3a is 3 sine a minus 4 sine cube a. Cos 3a is 4 cos cube a minus 3 cos a. Tan 3a is 3 tan a minus tan cube a by 1 minus 3 tan square a. And cot 3a is equal to 3 cot a minus cot cube a by 1 minus 3 cot square a. Right? Now, we have seen cos 2a is equal to 2 cos square a minus 1, children. Right? Now, can we write 2 cos square a as 1 plus cos 2a? By just taking this one to the, cos 2a to this side, and 2 cos square to the other side. Then from this, we can also write cos square a is equal to 1 plus cos 2a by 2. That means from this we can say cos a is equal to plus or minus root of 1 plus cos 2a by 2. Right? Likewise, cos 2a is equal to 1 minus 2 sine square a. Now, this can be taken as 2 sine square a is equal to 1 minus cos 2a. That means sine square a is equal to 1 minus cos 2a by 2. That means you have sine a is equal to plus or minus root of 1 minus cos 2a by 2. We know sine a and cos a. From this, you can also calculate tan a, which is sine a by cos a. Therefore, you will have it as plus or minus root of 1 minus cos 2a by 1 plus cos 2a. Right? Now, we'll see what is sine 18 degrees. Now, till now, we have deduced sine 75 and 15 degrees. Now, it is 18 degrees. Now, we'll just say let a is equal to 18 degrees, children, for our convenience. Now, what if I multiply with 5 on both sides, then I'll have 5a is equal to 90. because 5 into 18 is 90. Then this 5a, we are writing it as 2a plus 3a. Why we are writing in terms of 2a and 3a? Because just now we have seen the formulas with 2a and 3a, isn't it? So we will apply, we will just write 2a is equal to 90 minus 3a. Then we'll go for applying of sine a on both sides. Sine 2a is equal to sine of 90 minus 3a. Sine of 90 minus theta is cos theta, isn't it? So you're getting it as cos 3a. Then what is sine 2a formula, children? You have it as 2 sine a cos a. And cos 3a is 4 cos cube a minus 3 cos a. Now, on the other side of the equality, take cos a common. Then you will have it as 4 cos square a minus 3. Just cancel cos a on both sides. Then you will be left with 2 sin a is equal to 4 cos square a minus 3. Now instead of cos square a, we will replace it with 1 minus sin square a, which is our trigonometric identity. Then if you expand this and rearrange the terms, you will have it as 4 sin square a plus 2 sin a minus 1 is equal to 0. Now, this equation is like a quadratic equation in terms of sign, isn't it? So, your formula for any quadratic expression, quadratic equation ax square plus bx plus c equal to 0 is x is equal to minus b plus or minus root of b square minus 4ac by 2a. Now, instead of x, you have sine a over here, right? So we will say sine a is equal to minus 2 plus or minus root of 2 square minus 4 into your a value is 4 again, minus 1 is c value divided by 2 into 4. Then you will have it as minus 2 plus or minus root of 4 plus 16 by 8. 4 plus 16 is what? 20. 20 under root is nothing but 4 into 5 under root. Root 4 is 2. So it is nothing but 2 root 5. Now, if it is 2 root 5, we can always take 2 common from the terms. Then you will have it as 2 into minus 1 plus or minus root 5 by 4. Now 2 and 8, they get cancelled and you will be left with 4 in the denominator. And look at the numerator, children. We need to just think logically over here. Minus 1 minus root 5 and minus 1 plus root 5. Now just throw some attention on that. Root 4 is 2. Root 5 is more than 2, isn't it? So minus 1 plus root 5 will be a positive value. Minus 1 minus root 5 is a negative value. Now, what is that we have taken it as A? A is 18 degrees. Where is 18 degrees? In the first quadrant. In the first quadrant, how is sign? Sign is positive, isn't it? So you cannot afford to take a negative value in the first quadrant. Therefore, the value of 18 degrees, it should be positive. So we will conclude saying that sine 18 degrees is equal to root 5 minus 1 by 4. Now, making use of this, we will try to calculate what is cos 36 degrees. Cos 36 degrees can be taken as cos 2a. Why? Because we have taken a is equal to 18 degrees. Now, this can be taken as cos 2a is 1 minus 2.
Usha madam, please unmute yourself.
Now children, cos 2a is 1 minus 2 sine square a, isn't it? So, we will just take 1 minus 2 sine square 18 degrees. Now, 1 minus Sine 18 degrees is root 5 minus 1 by 4, right? Root 5 minus 1 by 4 whole square. Look at this, just we are substituting and taking square of this. Then you will have it as 1 minus 2, 5 minus 2 root 5 plus 1 by 16. Why? We are just taking it as a minus b whole square and we are expanding this. Then 5 plus 1, which is 6. And of course, these two are getting cancelled. You will have it as, by taking LCM as 8, you will have it as 8 minus 6 minus of this minus plus 2 root 5, which is 2 plus 2 root 5 by 8. When you take 2 common, you will have it as 2 into root 5 plus 1 by 8. Then finally, you are left with cos 36 is equal to root 5 plus 1 divided by 4. Okay. Now, we'll see the next problem, children. Sine 36 degrees. Sine 36 can be taken as root of 1 minus cos square 36 degrees. How did we get this? By making use of the identity, isn't it? Trigonometric identity. Then cos 36, just now we have calculated it as root 5 plus 1 by 4. Just substitute that value. Then you will have it as 1 minus 5 plus 2 root 5 plus 1 by 16 under root. Then on taking LCM and simplifying, you will get it as 16 minus 5 plus 1, 6 minus 2 root 5 divided by 16, right? 16 minus 6 is 10 minus 2 root 5. Root of 16 is 4. And of course, root will be there for the numerator. Therefore, sine 36 is equal to root 10 minus 2 root 5 divided by 4, right? Then quickly we will see what is cos 18 degrees. Cos 18 can be taken as root of 1 minus sine square 18 degrees. So sine 18 degrees, we know, children, that is root 5 minus 1 by 4 whole square. Just expanded this and we have taken the LCM. You will have it as root of 16 minus 6 plus 2 root 5 by 16 under root. This is 10 plus 2 root 5 by 16 under root, right? So we can say cos 18 is equal to root of 10 plus 2 root 5 divided by 4. Now children, remember, you have root for 5 and this 10 plus 2 root 5 is again under root, but there is no root for the denominator because root 16 we have taken it as 4. Now, likewise, sine 22 and half degrees. Sine 22 and half degrees, just now we have seen sine A, cos A formulas, right? We have deduced that from cos 2A. So the formula is sine A is equal to root of 1 minus cos 2A by 2. So we'll just apply this. Cos 2A. What is A, children, here? A is 22 and half. Double of this is what? 45 degrees, isn't it? Then cos 45, already we know it is 1 by root 2. Just we are replacing cos 45 with 1 by root 2. Take LCM, then simplify. You will get it as root of root 2 minus 1 by 2 root 2. So sine 22 and half degrees is root of root 2 minus 1 by 2 root 2. Now similarly, you can calculate cos 22 and half degrees, tan 22 and half degrees, and also cot 22 and half degrees. Now you need to deduce this by making use of what logic we have seen here, right? 22 and half degrees, if it is taken as A, then double of that will be 2A. 2A is 45 degrees. 45 degrees is a standard value, so you can calculate it by substituting that particular value. Now, the
Usha
next...
madam, we'll take up this later.
Okay. Now children, there are some practice questions for you. I want you to take the screenshot of this and I want you to solve these problems so that you will be in touch with all the formulae. When you practice the questions, I'm sure you will be thorough with the formulae also. Just try them out. There are some 2-mark questions and also 4-mark questions. Please take the screenshot. Thank you.
Thank you, Usha madam.
Thank you, madam.
That was really so wonderful for you to deduce all those submultiple and multiple angles. Dear students, it looks very easy when you're listening to the class, right? Oh, it's sine to a, cos to a, there is nothing much that you need to do. But once you put it on paper by your own self, like if you are doing it on your own, then these problems will remain with you forever. We never recommend as mathematicians to by heart anything or practice the formulae, writing it so many times. No, please try to understand the logic that madam has explained in replacing a with 2a with a by 2, and deducing all the multiple angles and submultiple angle formulae. Also, when you solve more and more number of questions, not only in one method, in various methods, then you will be able to remember this formulae very well. Madam has shown you a path. You take that path, go ahead, take the textbook, solve all those questions, including the formulae. You please try to deduce them on your own. Whenever you have a doubt, you can as well revisit the YouTube video. Is it not? You have the support now with this. I don't want you to copy it as it is. I want you to do it on your own by taking the logic, by following the logic that madam has told you. And I'm sure you will do it. Okay?
Practice makes you perfect, children. So,
Yes.
as madam is telling, practice and practice till you are satisfied with what you are doing, right? So, please keep practicing the things.
Right. And thank you, Usha madam,
Thank you,
for
madam.
such a wonderful start. Hope for the
Thank you.
next session, the students will be ready and will be eagerly waiting to learn few more concepts and few more formulae. Thank you
Yeah.
so much for taking so much interest. Thank you.
Thank you, ma'am.